Hey everybody, this is Larry, this is me going with Q2 of the Biweekly Contest 98, minimum score by changing 2 elements. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So this one could be very tricky to parse. There's just a lot of things, a lot of information coming at you, to be honest, and you're trying to figure out how to kind of connect the pieces, right? So you want to minimize the score where there's a low component and a high component. And of course you sum the high and the low, so you have to try to figure out how to balance these two, right? The thing about the low score is that if you, one idea is that when you remove, when you change one of the elements, well, if you change it, you can always change it to one of the other numbers, right? Or even in one of the examples, you could change it to the same number that's not one of the numbers. So that means that for me, the low score can always be 0. So therefore, we can almost kind of throw it out because we always want to, we can effectively do it without changing the other thing. And then the high score is just the range of the array, right? Meaning the max minus the minimum. So from that's how I kind of came up with my solution. Is that I first sorted because I'm lazy to get the thing, and then this mess is kind of just basically saying, okay, let's say you have this sorted thing of like A, B, C, D, E, F, G, H, whatever, right? Dot, 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 and H is the biggest number, right? Well, the thing is that, well, after you sort it, there are a lot of things you can change still, but let's say you change this middle number D, right, to anything. I mean, and of course, if you change it to a bigger number, you're just being silly because then now you raise the score, right? Because the base score now is, yeah. So basically, you don't ever want to change the middle number per se. And then now you think about, okay, we have 2 numbers to change. What would it look like? Well, if we change these 2 numbers to one of these other numbers, so you can effectively change it to CC or HH or DD, it doesn't really matter, right? But the idea is that, well, now the low number is going to be 0, and then the range is just H minus C, right? And then the other thing that you can do, so that's one way to get a solution and one possible solution, right? And that's actually reflected in this one. Basically, it's the max number minus, the third number, right? Because now that's the range. And then the other one to think about it is, changing the A to a B and then an H to a G. Because then now, the high score is B minus G or G minus B. And of course, the low score is still 0, right? So yeah, so that's another way of doing it. And then the third way of doing it is just changing the last 2 numbers to F, so that now you still have a low number and an A. And you can also change it to AA as well. It doesn't really matter, but it's just about, now the unique numbers are like this, and the low numbers are like this, and F and A, and that's basically the idea. And of course, like I said, the idea is that if you change it the other way, like let's say we change this to E, it doesn't change the score, right? It's still A and H. Of course, you change the low to H, but yeah, but that's basically that. And of course, by just general proof, you could prove that it's more optimal because that, if H is bigger than F, meaning that they're different numbers, then F minus A is going to be smaller. So you want to actually almost, do something like that, right? Kind of proof. So that's basically the idea. You can probably do this without, so yeah, the complexity, right? The complexity is obviously here is n log n, and then this is O of 1. There's just 3 subtractions and a minimization. But of course, if you're really careful, you can actually do this in linear time, right? It's just about getting the min 3 numbers and the max 3 numbers. And of course, the code would be much harder to write. It's probably not that much harder, but you would have to be more careful about it, at least for me. I would have to be careful about it. That's why I didn't do it that way. But you can do this in linear time and constant space. This is about 3 minutes. So yeah, that's all I have for this one. Let me know what you think. And you could watch me self live in contest now. Okay. Let's see, let's go by changing 2 elements. Low score is minimum of I minus J. Max of so the score is the sum of the high and the low. So here the minimum possible score of the deltas. Okay. So max is 3, and then this is 2, and then this was the original one is 5, right? Again, maybe the first one we do is sort. But, then it becomes minimum value. And you would actually return this to oh, you would actually set this to the minimum, so the minimum will always be low. Okay. At most 2. People got this already. No one yet, maybe. But basically, you want to switch. So basically, it's min of at least 3 numbers. Okay, the biggest number minus or so this is replacing. There should be one more. Now this is this one. Yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and an explanation and everything. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.